Good morning, all you fantastic fours out there. So lovely to have you with us again today. We have moved on to an entirely different topic today, but I will take the time to quickly go through yesterday's topic, but quickly because I don't want to distract us from today's work. I hope that your times table challenges are going well, and I also want to just remind you that if your teachers from school are sending you work that you are struggling with at all, please drop me an email so that I can maybe look at including that in some of the lessons to come. I know that these lessons are quite sort of topic driven, and actually in a classroom we would spend quite a lot more time practicing them just to make sure that they were consolidated before we moved on to a new topic. So I realize that we're moving through topics quite quickly, and I hope that this is just giving you sort of a starting point so that when you do it with your teachers in class, you're like, oh yes, I know how to do that. Okay. So a reminder, any questions, any information you want to give me about how well your times table challenge is going, anything like that, drop me an email on grade4@worksheetcloud.com. Also a reminder that after the video, you can click on the link above and get the worksheet that checks that you've managed to absorb some of what today's work is all about. Let's go on to what today's work is all about. So we are looking today at input and output machines and tables. This is the precursor, or the thing that comes before looking at patterns, which is where we'll go after we've looked at input and output. Before we do anything else, let's quickly, even before the lesson objectives, let's go back and quickly look through yesterday's homework. All right, so yesterday we were looking at multiples, factors, primes, composites, which are 4 different concepts but quite closely linked. So just to remember that I use M for multiples, make up. So multiples, anything that's made up of something is its multiple. So for example, multiples of 5 are all numbers in the 5 times table. So all numbers made up of 5s. And I remember that factors fit in. So factors are things that fit into something. So for example, a factor of 10 would be 1, 1 fits in, 2 fits in, 5 fits in, 10 fits in. So those are factors of 10. So right, having a look at multiples, write down the first even multiple of 5. So I'm looking for something in the 5 times table that's also even. Not 5, 10. 10 would be the first one in the 5 times table that is even. There's our answer. Next one, how many multiples of 3 are between 10 and 20? So first up, I'm going to have a look at what are the multiples between 10 and 20. You don't have to write them down. That wasn't the question, but I'm going to. So if I'm going to do the 3 times table, but I'm only going to start writing down when I've passed 10. So 3, 6, 9, 12, 15, 18, and the next one is 21. So that's outside of 20. So these are the 3 that are between 10 and 20, and your answer then is 3, because the question is how many multiples of 3 are between 10 and 20. The next question was, is 45 a multiple of 7? In other words, does 7 fit exactly into 45? I'm going to do my 7 times table quickly and check. 7, 14, 21, 28, 35, 42, 49. No, I've already passed it, and it wasn't in the 7 times table, so then my answer will be no. Next one, find all the factors of the following numbers. You may use any method. Oh, it looks like I've accidentally put an extra number over there. Those questions underneath are the ones that should go into there. So find all the factors for the following numbers. You may use any method you choose, but I've left enough space for you to draw factor trees, which is my preference. Don't forget to list the factors below the factor tree. I hope I've got space here. All right, so factors of 8. I always start with the smallest. 1 times itself gives me 8. 2 also fits in, 2 times 4, and that's all. So factors of 8 are 1, 2, 4, 8. Factors of 12, I think I'm going to have to do one outside of the page. So I'm drawing my tree trunk. I'm using factor trees. Let's just make some space underneath. 12. So I'll always start with 1. 1 times 12 gives me 12. 2 times 6 gives me 12. 3 times 4 gives me 12. So factors of 12 are 1, 2, 3, 4, 6, and 12. Factors of 20. Oh, again, I didn't leave enough space underneath. 20. 1 and 20. 2 and 10. 4 and 5. You may have taken a little longer to get there. That's just because my times tables are a little bit quicker than yours, I'm sure. But as you practice it, it will get easier and easier. Okay, and then you needed to write down your factors underneath. So 1, 2, 4, 5, 10, and 20. Yeah, the last one I'm just going to do on the side here. So we're looking for factors of 25. 1 and 25. Everything has 1 in itself. 2 doesn't, 3 doesn't, 4 doesn't, 5 does. 5 times 5 gives me 25. And that's actually all there is. So factors of 25 are 1, 5, 25. Okay, I hope that went all right. Remember that you could have used looking in your head as we showed you last time, or you could have done the rainbow method. It doesn't matter. As long as you ended up with these answers underneath, that's the key bit. I just find that doing the factor trees is what is easiest for me in making sure that I don't miss anything by mistake. Okay, the last question, circle the prime numbers in the cloud below. So remember, a prime number is a number that only has 2 factors, 1 in itself. And the little rhyme I used was, if my factors are 1 in myself, then I sit on the prime number shelf. So looking for primes, 5 has factors of only 1 and 5. 7 has only 1 and 7. 2 has only 1 and 2. 3 has only 1 and 3. 4 has more, 8 has more, 6 has more, 9 has more, 12 has more, 10 has more, 11 has only 1 and 11, and 15 has more. So those are the prime numbers there. As a quick aside note, 2 is the only even prime number. And the reason for that is because every other even number 2 fits into. So this is a question that teachers quite like to ask to check. They ask, what is the only even prime number? And the answer is 2. So that's a question that comes up quite often. Bank that in your head for another time. Let's go back to our lesson for today and look at our lesson goals. We were going to look at input and output machines. So quite a few lesson goals, but they're all quite closely linked. So to be able to use single-step input-output machines to arrive at answers, to be able to work backwards through the single-step input-out machines to arrive at what you started with, be able to identify the rule if the input and output are given, and be able to see that a table can also represent the same information. So that seems like quite a lot, but I think once we get onto looking at some practical examples, it will be easier. So I've seen these drawn many different ways, input-out machines. We can see on the one side of the screen, we've got a number that goes in, we've got a function or a rule, and then on the other side, we've got an output. All right, so all we need to do is put in the rule in the middle, and then we can work out what our inputs and outputs are. So what I'm going to do is to go across to the whiteboard and just quickly look at let's just look. I've put him in there, and let's have a look and let's draw. So let's say, for example, that our rule was times 2. So our rule was times 2. Then whatever comes in the input, we then times it by the rule, we do the rule to it, and we find our output. So if, for example, I put a 4 in, I would then say 4 times 2. And my output would be 4 times 2 is 8. If I put in a 3 times 2 is 6, my output would be 6. If I put in, what number would you like? A 7. 7 times 2 is 14, then my output is 14. So you can see whatever it is that goes in through the input, we then just do the rule to it, and we can get our output. Let's give a different rule for a practice quickly. Let's give the rule of divided by 3. So we can put any rule in the middle. We just need to then apply each thing to that rule. So I'm going to put down some numbers here, and you can quickly work out the output answers for yourselves. So I'll use different colors so it's clear which are coming out on the other side. Oh, sorry, I'm not paying attention here. I need to give you ones that you'll be able to do. So you don't have to write these down. You can just see if you can get them in your head. So starting with 6, we then go 6 divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 15 divided by 3 is 5. 18 divided by 3 is 6. So you can see whatever the rule is, we just take the number we put in through the input, we then get to our answer. So let's give a different rule. We've now done times and divide. Let's try a plus. I'm going to put down 5, see if you can work them out. Now that you've watched me do it, I think I can use the same color on both sides. You can see that whatever is on the top will be the one on the top on the other side. So this is where mental arithmetic is very important to help you be quick. So if 7 plus 5 takes you a while to work out, then you will it'll slow you down from getting your answers. 7 plus 5 is 12. 5 plus 5 is 10. 4 plus 5 is 9. 2 plus 5 is 7. Okay, so input goes through the rule and comes as an output. One more rule, and I'm sure you've guessed we've done the other operations. So let's use a subtraction one this time. Well, it's minus 2, so I'm sure this one is not taking you very long. So 8 minus 2 is 6. 100 minus 2 is 98. 5 minus 2 is 3. And 2 minus 2 is 0. So there's my input and my output. So that's a simple input and output machine. Now I am going to ask you to do these ones on a piece of paper. So I'm going to give you 4. I'm going to put the rule in the middle. All I'm going to ask you is to write down the output, the answers. So you don't have to put the input, you can just put the answers. So you can number your answers 1, 2, 3, and 4. I'll give you 4 for each one. I'll put the rule in and I'll put the input numbers. You just give me the output numbers. So practicing, and the first rule we're going to do is plus 7. I'll use different colors for this one. If you need any longer, just pause the video quickly, and then when you've finished, you can start again. So 8 plus 7 is 15. 9 plus 7 is 16. If you were paying close attention, you would realize that because this is just one more than that, your answer over here will be just one more than that. Okay, but it doesn't matter if you didn't notice that. 16 plus 7 is 23. And 0 plus 7 or 0 plus 7 is 7. Okay, so plus, we've done a practice with plus. Let's now do a practice with next operation. So again, you're just writing down the answers. Let's go with a rule, -5. If you need any more time, just pause the video. So 6 minus 5 is 1. 12 minus 5 is 7. 14 minus 5 is 9. 21 minus 5 is 16. Just as an aside note, I am deliberately often choosing ones where we have to cross over a 10. So going from 12 to 7, we're crossing over the 10 mark. And going from 21 to 16, I'm crossing over the 10 mark. And the reason I'm doing that is because these are often the areas where our mental arithmetic lets us down. And so this is also a way of me forcing you to practice some of that while we're going. Okay, third rule. We've done plus and minus. Let's do a multiplication rule. Times by 4. If you need more time, just pause the video. Perhaps for the last 2 you might, if your 4 times table needs a bit more practice. 4 times 4 is 16. 5 times 4 is 20. 9 times 4 is 36. And 12 times 4 is 48. Last one. And this time, we're going to get a little bit more grown up, and I'm going to take out the picture of a robot. And instead, I'm very boringly going to just put a box here. And my rule is divided by 2. Works exactly the same. Whatever you have, you put into the rule, and then you get your output. So 4 goes in, and your answer comes out. Okay, if you're having any difficulty with this one, just pause, give yourself a chance to finish, and then join us again. So 4 divided by 2 is 2. 10 divided by 2 is 5. Another way of asking yourself these is how many times does 2 go into 10? And we go 2, 4, 6, 8, 10, 5. So that's how we got our answer of 5. I'll use the same process for number 3. How many times does 2 go into 14? 2, 4, 6, 8, 10, 12, 14. 7 times. So my answer is 7. And 2 into 20, or 20 divided by 2 is 10. There are our answers for that one. Back to presentation. So just a reminder what the machines do. Whatever the machine's rule is, you do that to the input number, and we've done the practice. Okay, now we're going to try and go backwards. So what if I did this? I said our rule is times by 4. And this time, instead of giving you the question, I gave you the answer. How would we find out what it was that got put into the machine to result in this number? I should actually draw my arrows on the other side. Right, so we got 16, we got 12, we got 24, and we got 4. But what did we put in? Another way of asking number 1 would be to say, what times by 4 equals 16? How many of you figured out the answer already? Well, what you can do is you can count in 4s until you get to 16. So 4, 8, 12, 16. So 4, let's check if that works. 4 times 4 is 16. So we know then that our answer, or our question that we put in was 4, because 4 times 4 is 16. So what can we do? Well, what we could do is to look at the opposite operation from times. So times is often the opposite of division, or is always the opposite of division. Not often, it's always. So plus and minus are opposites, and times and divide are opposites. 16 divided by 4 gives me 4. So when we're going backwards, we're using the opposite operation. Let's try that with this one. So, looking at number 2, what do you think you'll be able to get for your answer? Or your question, the number that went in. If we go 12 divided by 4, we get 3. Another way of asking that is, how many times does 4 go into 12? How many times does 4 go into 24? 4, 8, 12, 16, 20, 24, 6. So my answer is 6. You could have said 24 divided by 4, or you could have said how many 4s in 24. So this is working backwards through the machine to find your question. 4 divided by 4, or how many 4s in 4? 1. And we can check. 1 times 4 is 4, yes. 6 times 4 is 24, yes. 3 times 4 is 12, yeah. 4 times 4 is 16. So we have now gone backwards through our machine, and we've got our questions from the answer. One more thing that we're going to try and practice today what if we know the input and the output? Can we then work out the rule? I think that you guys are smart enough to do that. Let's have a look at an example. I'll give you a moment to look at that and see if you can figure out what the rule is. What did we do to 1 to end up with 2? And if you think you've got it, let's check it. So if I said we did something to 1 and we ended up with 2, I could try 1 plus 1, which equals 2, which is true. I could also try 1 times 2, which is equal to 2. That's also true. But the rule has to be the same for every single one of those answers. So I can check to see which one of those is right. So if I decided to look at the first one, 1 plus 1 as my rule, then I need to use that one for number 2. So I'm going to look at 3, and I'm going to say 3 plus 1, that's 4, not 6. So this rule now is not the one I want to look at. Let's try with the second one. Looking at the second rule. So 1 times 2 equals 2. Let's have a look. 3 times 2 equals 6. Okay, that one is working. Let's check through the others. So 2 times 2 gives me 4, yes. 8 times 2 gives me 16, yes. So then I've been able to work out my rule, which was times by 2. So now we've worked out how we can work from our numbers and our rule to get our answers. We've worked out how to go from our rules and our answers back to our questions. And we've also worked out how to look at our question numbers and our answer numbers and manage to work out the rule. So those are the 3 things that we're going to practice today. We will actually come back and do the table. No, let's do the table very quickly because it's pretty much the same thing. So looking at a table is just a different way of doing it. So instead of having the rule in the middle, we just have a rule and we've got our numbers that would go in and our numbers that would go out. So we've got our input number and we've got our output number, which is your input times 2. So I've put the rule as part of my output. So that's how I will work. There are slightly different ways to do it, but for now, that's good enough. So we know that when 5 goes in, I get a 10 out. When 4 goes in, I get an 8 out. When 8 goes in, I get a 16 out. So it's really just a different way of representing the same information that comes through the machine or through the block in the middle that goes through the rule. So it's just a simple way of doing it. Later on in grade 7, you'll have times when they start using X's and Y's and letters as the beginning of algebra. But for now, it's just a rule. So we get our answers. So sometimes your rule will be written on the side, sometimes above the table, and you'll just have the titles for your columns being input and output. Sometimes it'll be rows that have input and output. But it's just the same thing as when we put it through a rule. We've got something that goes in, goes through a rule, and we get our answer. That's all for today, grade 4s. I hope that this made sense. It's the beginning of what comes before we get to the patterns, which we'll be looking at in the upcoming lessons, and finding out what are the rules that govern our patterns when we're putting our patterns together. Remember to email me, grade4@worksheetcloud.com, and after the lesson, just click on the worksheet link above so that you can check to see whether you've mastered what it is that we've covered today in today's lesson. Have a fantastic day.